going to solve systems of linear equations with three variables. Whenever you have three variables, you have to have at least three equations. The first thing you need to do is you need to get your equations organized and get them, most of the time you want to get it set up like I have here, where x, y, and z are all on the same side. And then from there, you can do lots of different ways. We have learned how to solve these by graphing, which graphing for these would be pretty awful, to be honest. You don't want to do these that way. But you could do Cramer's rule with this, where you set up a determinant on the top and a determinant on the bottom, and you solve for each one of those. You could also do substitution. But the way that I like to do is I like to do these with elimination. So that's what I'm going to show today. And the first thing you want to do when you do elimination is you want to pick any two equations and eliminate one of the variables. So what I see first is I'm going to pick these two equations. And I'm going to run a negative through our top equation here. And then recopy the one below. Now a big problem with these types of problems is staying organized. You need to stay organized so you see what's going on here. You can see the z's are eliminated. So we've got negative 5x minus y equals 1 when we add those together. Now we're down to one equation with just two variables. Now what we want to do is we want to pick any other two equations and eliminate the same variables. So I'm going to pick these top two now. And I need to eliminate z just like I did right here. So then I'm going to run a negative through the top. So negative x minus y minus z equals negative 4. And then just recopy the bottom one. And then add these two together again. As you can see, the z's cancel out here. So we've got 8x plus 2y equals negative 4. Now what we're down to is we have two equations with two variables, and most importantly, they are the same variable. So now I'm going to do elimination again. And this time, what I'm going to do is I'm going to multiply this one here by 2. When I do that, you'll be able to see that my y's cancel out here. Those go away. We've got negative 2x equals negative 2. So x equals 1. Now from there, the easiest thing would be to do substitution here. So I'm going to plug this 1 back into this equation here. This is a negative 5. Add 5, this would be a 6, and then we got to move the minus sign over, so y has to equal negative 6. And then if I put both of these back into one of the original equations, I can solve for z. So 1 plus negative 6 would be negative 5, plus z equals 4, so z has to equal 9. Now what we should do with this is we think this is the correct answer. So what we need to do is we need to plug this in to see if this actually works. So we've got 9 minus 18 is negative 9, plus 9 is 0. 4 minus 12 is negative 8, plus 9 is 1. So because that works on your other equation, that is your answer. Moving on to the next one. You want to do the exact same thing here. Alright, so what I see is I see this negative z here. Alright, I'm going to multiply this by 2 and then add it to this one right here. So 6x plus 4y minus 2z equals negative 30, and then recopy the one below it. Add those together, 11x plus 7y, z's go away, equals negative 30. Alright, and then I'm going to do this top one and the bottom one, but this time I'm going to multiply that one by 3. So I've got 9x plus 6y minus 3z equals negative 45. And then recopy the one down below. And then add these together. 12x plus 7y, the z's go away again, equals negative 34. Now this one could be a little bit more of a mess, but we got lucky here. We've got a 7z and a 7z. So I am going to run a negative 1 through this one, and I've got negative 11x minus 7y equals a positive 30. When I add those together, the y's go away, x equals negative 4. Then from there, plug it back into one of your equations. I'll plug it back in here. This is a negative 44, so we add 44 over. This becomes a 14 divided by 7. Y has to equal 2. And then we plug these back into one of the originals. I don't know if it matters. Let's see. Negative 12 plus 4 would be negative 8. Then we've got a negative z, so negative 8, add the 8 over, that becomes a negative 7, divide by negative 1, so z has to equal a positive 7. So I'm thinking right now, my answer is this. Let's check it. Negative 20 plus 6 is negative 14, plus 14 is 0. Negative 12 plus 2 is negative 10, plus 21 does give us 11. So there is our correct answer there. Make sure you plug it into all of them to make sure that you have the correct answer. Another one. You know, what it's starting to look like is, well, let's just eliminate z every time. It depends on the problem. But what this looks like is, well, let's eliminate z first. Alright, so normally what we do is, well, I'm going to add these two together. So when I do that, I get 3x plus 9y, z's go away, equal 8. Then I'm going to take the top one and the bottom one, take this one times a negative 3. So I've got negative 6x minus 12y plus 3z equals negative 24, and then recopy, and what we see here is the top and the bottom are pretty much the same thing. Cancel, 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 cancel. 0 equals 0. So what that tells us is we have an infinite number of solutions here. Alright, we don't know exactly what the answer is going to be here. So that's why it ends up being infinite. Alright, now what I would tell you to do with this is before you get started, see if you see anything like this. Alright, if we would have looked right away at top and bottom, you could have saw, well, yeah, there's only a factor of 3 that's the difference between those two, and then they're exactly the same. That would tell you infinite solutions then. Alright, next one. Alright, now really quick, if you were to go back here and everything cancels except for this, so say you had a false solution here, that would mean that there is no solution. Alright, word problem. Alright, read it really quick. A person invests $10,000 for 1 year. Sum is invested at 3, at 4, and at 6. Combined interest earned at the end of the year from these investments is $475. The amount invested at 6 is the sum of the amount invested at 3 and 4. Find the amount invested at each rate. Well, your first thing that you need to do is you need to define variables here. Alright, so my x, I'm going to say the amount, dollar amount, at 3%. For y, dollars at 4, and $10 at 6. Now, if you do that beforehand, that would mean that once you get your answer, then you don't have to guess which one goes with which one here. I can just look back at that and then figure it out. All right? A person invests $10,000 for 1 year. Some of it's in one of it, another and another. Well, what that says is the amount in the 3% plus the amount in the 4 plus the amount in the 6 has to equal $10,000 here. For the next one, the combined interest earned at the end of the year from these investments is $475. Well, how we find interest in this situation is I equals PRT, interest equals principal, times rate, times time. Now what this is talking about is the combined interest. So we are trying to find the I here. T, it says, is 1. So this just acts like a 1. I equals the principal times the rate. Well, our x, y, and z are the principal, and our percentages are already in there. So we could go 0.03 x plus 0.04 y plus 0.06 z equals 475. From there, the amount invested at 6% is the sum of the amount invested at 3 and 4. All right, now, each one of these are the amounts. So the amount invested at 6% is not 6% times z. It is just a z equals the amount invested at 3 and 4, the sum of those two. So z equals x plus y. Alright, now we've got 3 equations, 3 variables. Now we're ready to solve this. Okay, and there's lots of different ways to do this. One way that you could do is we've got this set up for substitution. So we could plug this in wherever we see a z and a z, and then see what happens here. So we've got x plus y plus x plus y equals 10,000. And then I've got 0.03 x plus 0.04 y plus 0.06 times x plus y equals 475. Now what we need to do here is we need to run this 0.06 through here. So when we do that, x plus 0.06y equals 475. And now we need to combine like terms. So we've got 0.09x plus 0.1y equals 475. Now we're getting closer. We do have, and then with this one too, we can combine like terms, which we will right now. So we've got 2x plus 2y equals 10,000. All right, and down here, well, you can do lots of different things. I would probably say, well, let's get rid of the decimals. By doing that, we would have to multiply this whole thing by 100 here. And when we do that, we get 9x plus 10y equals 47,500. Now, the numbers got big, but now we can see, well, we're pretty much set up to do elimination here. Multiply this top one by -5, and we've got negative 10x minus 10y equals negative 50,000. Alright, normally I would say copy this one down again, but they are right on top of each other, so I'm just going to add these two together. I get the y's go away. I've got negative x equals negative 2,500. So I'm saying right now x equals $2,500 Alright, if I come back here and run x through, I don't know, right here, I've got 2 times 2500 is 5,000, subtract that over, 10,000 minus 5,000 is 5,000, divide by 2, gives us y equals 2,500. Then if I plug those back into our original, 2,500 plus 2,500 is 5,000, subtract that over, that means z equals 5,000. Now there is one very important part left to this problem. It does not say find x, y, and z. It says find the amount of the money invested at each rate. So what we need to say here is 2,500 at 3%, 2,500 at 4%, and 5,000 at 6%. Alright, make sure that you do that last step. That is very, very important. So we know what these answers actually stand for. This tells us, alright, they put 2,500 in the 3%, okay, in the 4%, and the 5,000 in the 6%. Very important information there to show. Alright, any questions on these? These take a lot of work. Don't be too disappointed if you screw up along the way. They're easy to screw up. Just be very, very careful as you go through these. Any questions? Please let us know.